So in the last couple of slides, I went over different kinds of functions that you can graph. Now we're going to look at functions that aren't really a specific kind of function, but more just, I'm going to give you some information. You need to graph something that fits that information. And this is, again, just really trying to get you used to reading mathematical language. So the easiest part of that is when we're just describing some points. So on this function that I'm about to graph, there's going to be tons and tons of answers to this problem because you can graph anything that has this information true. So because all I've done here is list some points, I just need to make sure that whatever function I draw fits this graph and has all these points on it. So the first one says that when x is -3, the y-coordinate is 2. So when I'm graphing that, I'm basically graphing the point -3, 2. When x is -3, the y-coordinate is 2, and I can't really see any lines on here, so I'm just going to kind of pretend I know where they are. So -1, -2, -3, the y-coordinate is 2, that point. So my function just has to go through that point. Same thing on the next one. When the x-coordinate is 2, the y-coordinate is -3. So I'm going to go over to where x equals 2, and the y-coordinate there has to equal -3. All right, so that's kind of the reverse of the point I just graphed. The next one says when x is 4, the y-coordinate is 1. So that is the point 4, 1. So I graphed that point. And then the next one has two statements, and I just stuck them together because it's easier to write it on one line than two. This is saying that f of -2 equals 0, so that's the point -2, 0, and f of 5 equals 0, so that's the point 5, 0. And if 2 points have the same y value, you can always do that, just kind of list them together like that. So f of -2 is 0, that's this point right here, and f of 5 equals 0, that's this point over here. Now, that's all the information I have about this function. So from there, I can draw any function that fits this information. So I need to draw something going from the left to the right. Remember, it has to be a function, so it has to pass the vertical line test. So one of the things I cannot do is I cannot go from like this point to this point to this point. That's not going to work because that just failed the vertical line test. So I'm going to get rid of that and draw something that actually fits. And I can draw straight lines if I want to, or I can draw curves. Most likely a function is going to have curves just because that's kind of how we generally draw functions. So I'm going from left to right, so from there to there. Then the next point I have to hit is that point over there. And then I have to hit this point, and then I have to hit this point. And I have to be going between left and right. I can't go right and then go left again. And then to the right of that, maybe it goes down, it could go up, doesn't really say. And that one could be going up. But I need something going left and right on that function. All right, so there's one possible answer. Another possible answer, and I'm going to draw this and then erase it just because you get the idea, it'll look kind of awful. This could be a function that works. Doesn't really say what's happening here, so I can just kind of make up whatever I want, right? That's another example of a function that fits all that information, but has a completely different shape. Now I'm going to get rid of it. All right, so there's sort of a simpler version of it. Okay, so then the next example, I don't exactly have points here. I have a couple that are points, and then some other ones that have more information. So the 2 points that I see on here are g of 0 equals 0, so that's the point 0, 0, and g of 1 equals 3, so that's the point 1, 3. So 0, 0, and then when x is 1, the y value is 3, so there's another point. Now the rest of these don't exactly say what g equals. So they don't actually say when x is 5, here's the g value, or when x is 1, here's the value of g. What they say is that the y value of g at the coordinate x equals 5, sorry, I said that really badly, the y value of g when x is 5 is greater than the y value of g when x is 1. All right? So the y value when x is 5 on this function is greater than the y value when x equals 1. So that means that if I know the y value when x is 1, the y value when x is 5 has to be something bigger than that. So when x is 5, I'm going to go all the way over to 5. The y value there has to be bigger than the y value when x is 1. And I actually know what the y value is when x is 1. It was 3. That whole thing is just 3. So the y value when x is 5 has to be bigger than 3. So over at 5, I need to pick a point that's higher than 3. So I picked 4. So I made g of 5 equal to 4. I already knew that g of 1 was equal to 3, and because of that, I made the y value at 5 greater than the y value at 3. At 1, I'm sorry, which was 3. So the y value when x was 5 was greater than the y value when x was 1. In other words, it's higher up. All right, so now I have the same thing when x is negative 5. The y value when x is negative 5 has to be greater than the y value when x is negative 1. And unfortunately, I don't actually know what any of those are. So this is saying that the y value when x is negative 5 is greater than the y value when x is negative 1. So since I don't know what either of those is, all I know is that the y value has to be greater at negative 5 on the x-axis than it is when x equals negative 1. So since I don't know what either of those are, I'm just going to make up a number for g of negative 1. G of negative 1, I'm going to make that negative 2. Right there. That's g of negative 1. I made this value negative 2. G of negative 5 has to be greater than that. So if g of negative 1 is down here, then g of negative 5 has to be a little bit higher. So it could be, here's negative 5 right here, it could be at negative 1, it could be at 2, it doesn't really say where it is, it just has to be higher than the y value when x is negative 1. So I made it much higher, I made it at 3, and therefore made it bigger than the y value when x is negative 1. Okay, and then this last one says that the y value when x is 2 has to be 3 times as big as the y value when x is 1. So the y value when x is 2 is 3 times as big, or equals 3 times the y value when x is 1. Sorry, it says negative 1, but it should say positive. All right, so y value when x is 2 has to be 3 times the y value when x is 1. So if the y value when x is 1 is 3, that's that right there, then the y value when x is 2 has to be 3 times as big as that. So this value was 3. G of 2 has to be 3 times as big as that, so it has to be 9. So G of 2 is going to be way up there somewhere at the point 2, 9. Right, and that's because it has to be 3 times as big as the y coordinate when x equals 1. So you can see how these are starting to get much more complex. The points were pretty easy to graph, but the statements are a little bit harder to read, and you're just trying to get some practice reading those. So let me graph this function, then I'm going to go back and go over these one more time. On the left-hand side, I can do anything that hits these points and is a function. So I'm going to go from negative 5 to negative 1 to 0 to 1 to 2 to 5. And then I'm just going to have some arrows go in either direction. Doesn't really say what the domain is, so they actually could just stop at the ends there. All we know is that the values that are listed have to be included. Okay, so now let me go back through what each of these statements said, because this is always really confusing the first time you see it, especially when I start saying the wrong numbers. That really doesn't help. So the first statement says that g of 5 is greater than g of 1. That means that the y-coordinate of 5, or the y-coordinate when x is 5 right there, has to be greater than the y-coordinate when x equals 1. That's true. I can see the y-coordinate when x is 5, this is g of 5 right here, is bigger than the y value when x is 1. Next one says that the y-coordinate when x is negative 5, that'd be over here, is greater than the y-coordinate when x is negative 1. That's right there. So g of negative 5 had to be bigger than g of negative 1, and it is because it's higher up. The y-coordinate's bigger. The last one, and this is probably the most confusing, says that the y-coordinate when x is 2, which is right up here, has to be 3 times as big as the y-coordinate when x is 1. So since the y-coordinate when x was 1 was 3, the y-coordinate when x was 2 had to be 3 times as big. So it had to be up there at 9. All right, so hopefully that made it a little bit clearer now that I've gone through that and kind of talked through it again. All right, so let's do another example. This one's mostly easier because it's mostly just points. This one says that g of negative 5 and g of 3 are both equal to 0. That's just saying two things in one. Negative 5 has a y value of 0, and 3 also has a y value of 0. I'm going to list all these, and then I'm going to go back and actually graph them. This says when x is 1, the y-coordinate is 4. When x is negative 1, the y-coordinate is 3. And when x is 4, the y-coordinate is negative 2. So I'm going to graph all of those. And let's see, the y values go up to 4, so I'm going to go up to 5. Down to negative 5. There's probably lines on here. I can't really see them, so we're going to pretend they're not there. Negative 5, 0 is the first point that I have, so that's there. And then I have 3, 0, that's there. I have the point 1, 4. I have negative 1, 3. And 4, negative 2. I'll give you a minute to look at those and make sure you got those graphed right. So negative 5, 0. I have a point at negative 1, 3. A point at 1, 4. And that means that I clearly did not label that correctly at 5. That was 6. So we'll just pretend that didn't happen. And then the point at 3, 0, and the point at 4, negative 2. All right, so the last two statements are a little bit trickier because they're not telling you values, they're telling you how two values relate to each other. So the y-coordinate when x is negative 2, which I don't know, is greater than the y-coordinate when x is 2, which I also don't know. So all that says is whatever the y-coordinate is when x is negative 2, so the y-coordinate over here, has to be greater than the y-coordinate over here. That's what I'm looking for. So I don't know what either of those is, but I know that the y-coordinate on this side at negative 2, oh, I made a mess of this, has to be bigger than the y-coordinate when x is negative 2. Or sorry, I said that backwards because I was trying to erase my mess. The y-coordinate when x is negative 2 has to be bigger than the y-coordinate when x is 2. So in words, y value when x is negative 2 is greater than the y value when x is 2. So at negative 2, I'm going to graph some random y value. I'm going to graph 1. There's negative 2, 1. That value has to be bigger than the value when x is 2. So I'll make that negative 1. All right, so the y-coordinate at negative 2 is greater than the y-coordinate at 2. And then the last part says that the y-coordinate when x is negative 4 is the negative of, or the opposite of, the y-coordinate when x is 4. So that is really saying that the two y-coordinates are opposites of each other. The y-coordinate when x is negative 4 is the opposite of the y-coordinate when x is 4. So at negative 4 and at 4, I do know actually the value at 4. So let me start with that. At 4, the y-coordinate is negative 2. That's right here. G of 4 is negative 2. At negative 4, I have to have the opposite y value. So since this point was 4, negative 2, when x is negative 4, the y value has to be the opposite of that. So that would be negative 4, 2. And that's just because those have to be opposites of each other. All right, so now I'm going to draw a function that goes from left to right. So from there to there to there. Make sure that you don't skip a point and go back to it, because then you're going to make it not a function. In fact, that one was almost not a function the way I just drew that, because it kind of looks like it might fail the vertical line test. So I'm going to fix that little section right in there. I don't want it to look like that. Let's say it goes more like that. All right, now it's not failing the vertical line test anymore, and I'm going to make it keep going, so I'll put an arrow going that way and an arrow going that way. There we go. All right, the trickiest part is that last one. So hopefully that's starting to make a little more sense. When we talk more about graphing functions, you're going to see that last statement show up a bunch. And that is actually going to relate to what are called even and odd functions, which are things that are mirror images or the reverse of a mirror image. Okay, that's it for today.